Now, if you are ready to go ahead and take this into a 3D printing environment, what we're going to first do is export this as a 3D model that our slicing software can understand. So I'm going to specify this geometry. I'm going to go over here to File, 3D Print, and you'll notice that this geometry has been selected. I'm going to specify unit type millimeter. Medium refinement is okay. I'm going to uncheck mark this send to 3D print utility. What this is going to do is it's going to give us a file export dialog. Here I'm going to name this our hello cup, and I'm going to save it. So right now it saved it as a 3MF. In particular, we actually want to save it as an STL. So I'm going to rerun this. I'm going to specify this geometry. I'm going to hit OK, and I'm going to do hello cup STL. So with this, I'm going to open up our Fusion 360 environment. This is what it looks like here. You will have access to different types of printers in the lab. In this particular case, I'm going to specify the printer Ultimaker 3. I'm going to go over into my Finder and find that hello cup, and I'm going to drag and drop it into the environment. Now you'll notice this cup is laying on its on one of its sides. That's okay, but it won't lead to the best print, and let me show you why. Here we have three options that we need to select. We need to select the material that we're using. In this case, we have a 3D printer with two types of extruders. So in this particular case, we're only using extruder number 1. It has a generic ABS material, and just so you know, the 3D printers will let you know what type of material that they have configured. I'm going to hit the slice button, and this slice button is taking into account these parameters here to specify how it's going to slice this particular model. So you'll notice here we have layer height, infill, whether or not we're adding support, and adhesion. So let's look at how what these look like. You'll notice here that after it's sliced through the model, we have a preview button. By hitting this preview button, we can actually go and see how this object is going to be 3D printed. You'll notice first it begins with this raft, and that's what this bottom geometry is called. Because this is a cylinder, it needs to adhere at one particular point to the bed of the 3D printer. You'll notice that we're climbing, and we're climbing at 0.1 millimeter layer height. So as we climb, you'll notice that it's not actually printing a solid geometry. Instead, it's going to use this honeycomb wafer structure to print a hollow object. And this is done to both reduce the amount of material you need to 3D print this cup, but also as a way of speeding up the 3D printing time. You'll notice that right now we're at a 9-hour print. And the thing that we need to take into account when looking at this particular object, this one will most likely fail if we send it to print. So I'm going to go back to this prepare view. I'm going to go over to the rotate option here, and I'm going to move this so as to see the inside of this geometry. Now the problem is the way that FDM 3D printing works is that it will print layer by layer, and the layer needs to have support beneath it in order for it to be supported. So take for example this geometry over here. It is hanging from thin air. Really, it's being supported by the left and right, but because gravity is acting upon this layer here, we'll likely have a caved in cup if we were to 3D print this as so. There's a couple of ways that we can get around this. We can go over here and we can hit support. What this is going to do is generate a scaffold-like structure so as to support these geometries. Let's look at what it would actually do. So there is the scaffold right here in the center, and it's being generated in order to hold up this geometry here. Now, this is also problematic because although it will allow us to print this geometry in this particular way, it's also going to introduce these marks on the inside and outside of this cup that will make it, mar the surface. Instead, what I'm going to do is I'm going to go over here to the rotate option, and I'm going to click on this option, select face to align to the build plate. So I'm going to select this top one and now here this bottom one, and this is a handy way to kind of quickly flip an object to its to the desired geometries. Now that I'm here, you'll notice that that this is laying flat and there are no geometries to support. It's all self-supporting. So I'm going to go ahead and hit slice again. You'll notice that I left support on, but after it computes its respective slicing operations, you'll see that in fact there are no support structures. We have that infill structure and there are no other supports being generated to print this cup. So I'm just going to unselect that support, and now we can dial in these different parameters. As a rule of thumb, I recommend not going above 30, above 30% infill. Anything below this, you're going to have some structural issues. Anything above this, you're going to have some issues with printing time. And especially if you're just trying to get a quick prototype, there's no reason for you to print at such fine resolutions here. So I'm going to bring this up to a 0.15, and you'll notice that that is going to help reduce our printing times here. Great. So we're now down to a 4-hour print, and everything looks like it will work well. The next step here is we connect our USB drive to the computer and we save this file, which will be saved as a .g code file, and that is what we will send to the 3D printer.